Engineering research has a vital role to play in all elements of our lives, from safeguarding buildings against earthquakes to improving healthcare through technological innovations and conserving energy with smart meters. The Engineering and Physical Sciences Research Council invests in skills and research that cross disciplinary and geographical borders and deliver a truly global impact. Sue Saville went to find out more.
Areas prone to earthquakes and tsunamis are benefiting from studies partly funded by the Engineering and Physical Sciences Research Council, or EPSRC. The work gives British building companies a competitive edge and is vital in London's insurance sector. At University College London, computer and physical modelling help predict outcomes from seismic events. This is the EPICentre, or Earthquake and People Interaction Centre at University College London, where experiments like these wave formations help engineers understand the impact of natural forces on structures like coastal defences and oil rigs. The work also informs global construction in areas liable to earthquakes and tsunamis.
A real earthquake is actually a live experiment, and so it allows us to study what will happen in reality. The EPSRC plays a fundamental role in enabling us to deploy after earthquakes, so to be rapidly there on site and to see what has happened and to understand the engineering problems, but also it sustains the research that we do, which is highly multidisciplinary and takes really the engineering to another level.
Engineering at a highly magnified level is taking place at the Hamlyn Centre for Robotic Surgery at Imperial College London. The centre's co-founder works here with one of the world's leading surgeons.
Innovation, in fact, involves many different aspects. Clinical innovation, that delighted to work with Lord Darcy, and we co-founded this centre, and he put in a lot of the clinical steer and also vision into this. Engineers are all renowned for developing sophisticated technology, clever technology, but less so we focus on developing technology that is accessible. So what we want to do is actually, develop technology such as robotics to make something that is suitable for privileged few into something that is mainstream.
Another mainstream application of research by the EPSRC is into the epidemiology of energy. That is, how we use energy in our homes, work and transport.
What we've done here is to pull together a large group of people in this building who are studying the problem of energy demand from a range of different backgrounds. So we not only have engineers who are very well versed in the technologies and the technical side, but also in the human side. So people come here to focus on the problem of energy, but bringing in all the expertise from the different disciplines.
It's working with people from different professional backgrounds that excites this doctoral student.
There are all of these different disciplines. Some of my colleagues do really distinct things to me, so I'm looking from a more social perspective, and I have people that are doing really technical work and modelling, and within that centre and afforded by the funding from the EPSRC is this ability to kind of work with different people and have a really broad understanding of energy challenges.
Very much part of the EPSRC's delivery plan to increase UK commercial productivity and technological connections in order to create a more resilient and healthy future on a global level.
EPSRC research is obviously predominantly trying to improve the competitiveness of the UK, but it happens in an international and a global context. So as research happens around the world, we can learn from that, bring that knowledge back into the UK and contextualise it for our own need.
Engineers trained here in the UK are collaborating across disciplines to provide solutions to global challenges.